Okay, so now we are moving to the final part. You must be seeing, you must be seeing this PowerPoint. Okay? So here we have discussed the three concepts related to the hierarchy of the significant predictors. Now the next step is related to proposing regression model. What do we mean by proposing the regression model? In the start, we have mentioned the regression model as y. So we will write it as y. Then we have b0 plus b1 x1 and so on. Right? So here y is actually willingness. Okay? We have b0 as b0 is the intercept or the constant. B0 is minus 3.321. So this is minus 3.321. Yeah, minus 3.321. Then we have regression coefficient of P1. Now, one thing is important when we propose the regression model, then we use unstandardized coefficient. We use unstandardized coefficient of or B. Why we use unstandardized regression coefficient B? Because they are in the actual unit and scale of measurement. Okay, so they are in the actual unit or scale of measurement. So it will be easier for the respondent or the person to give the answer. Right? So they are, as I am showing you, they are in the actual, they should be in the form of unstandardized coefficient also. Now here we are having the first independent variable. Okay. So let me check the first significant predictor. The significant predictor is departmental identity having unstandardized coefficient is 0.521. So let me write it as 0.521. This is 0.521 into the rating given to departmental identity. Means this is the value given to X1. Right? This is the first predictor, which is significant. Now we have the second predictor as the second significant predictor is youthfulness having regression coefficient as 0.415. So we are having 0.415 into youthfulness. Okay. And the third one is emotional connect, as this is the third significant predictor. Right? And the regression coefficient is the unstandardized regression coefficient for the emotional connect is, let us check the value. This value is 0.649. This is 0.649. Here the value is 0.649. Right? So this is our proposed regression model, which can be used for the prediction purpose. And if we substitute the rating given to these values, then we are having the predicted value of y. So through this, we are getting a predicted value of y. Right? So here we have considered only the significant predictor. But if we consider the insignificant predictor also, then it won't make any change because they are insignificant, means they are having low value of regression coefficient. So we are getting approximate same results in both the cases. So this is the proposing the regression model. This proposal or this regression model is used for prediction purpose or for forecasting purpose. By this, you can forecast or predict the values. Here we have discussed all this. So let me show you these slides. So this has been mentioned in the estimation of the model. Here we have discussed the significance of the overall model, including R square, adjusted R square, the concept of ANOVA. Then we have significance test for the regression coefficient also. I have explained the concept of partial regression coefficient, beta and B, how this beta has been tested, and these all have been made. And finally, we have mentioned the regression model also. Now we are discussing the last part, which is actually the second part. It is related to assumptions of the linear regression model. So first one is the linearity, how the linearity can be checked. So linearity can be checked using a scatter plot that I have mentioned, that scatter plots have been examined between the independent variable and the dependent variable. These are the scatter plots. They are available in the visualization also, even in Excel also. So that is the independent variable. The second is the error term should follow normal distribution. So for that purpose, we are using histogram of residuals and normality plots. Let me show you the output. In the output, we are having this, right? So here in the output, you must be seeing the output. Here we are having histogram. Here histogram in between the dependent variable, rebranded liking, and the standardized residual. So as you see, they are following the residual. Right? So this is the normal curve for the residual. Right? Means residuals are following normal distribution. Is it okay? Right? This is a histogram and the corresponding frequency curve. It resembles the normal distribution. So we can say that our residuals are following normal distribution. Right? In the previous lectures, when we were discussing the normality, then I have discussed the normal probability plots also. So this is the shape of the normal probability plots, right? Here on the x-axis, we have the observed values, and on the y-axis, we have expected values. And if both values are same, then we are getting the straight line at the 45 degree. So if this line represents that we are getting observed values and expected values which are equal. And these expected values are estimated considering that distribution is normal. So if distribution is actually normal, then we are getting equal observed and expected value. So most of the points are lying on the in this 45-degree line. So we can say that normal approximation has been fulfilled. So I am showing you, if we consider the histogram of residual, then the curve should be just like a bell shape. If bell shape curve is there, then it means we are having normality of the residual, right? This is the histogram of the residual. And if you are considering normal probability plots, so obviously normal probability plots is being made using observed values on the y-axis and estimated or expected values on the x-axis. And if points are lying on the 45-degree line, means most of the points are near to the 45-degree line, then we can say it is following the normal distribution. If they are much deviated from these two concepts, mean they are not following bell shape or they are not lying on the straight line, then we can say that it is non-normal in nature. So these two assumptions has been checked. Now the next assumption is related to multicolority. Multicolority means the actual assumption is there should not be correlation between independent variable. But if there is significant correlation, means multicolority means there is high correlation among predictors among independent variable. If this is the case, we have a problem of multicolority. Let us discuss this problem. Right? So what happens if this problem occurs? It violates, though it doesn't violate the assumption, but the variance become very high. If the variance becomes very high, then the confidence interval also becomes broad. So confidence interval becomes broad. So value of t becomes low. So value of t becomes low means our predictors comes out to be insignificant. So what happens? We have high f value, right? This f value is significant, high r value means overall model is significant as well as strong, but most of the independent variables become insignificant, right? Because t becomes low, so h naught is being affected. So we tend to believe that beta is 0. So this is the problem. There are some more problems that sign of the regression coefficient may be different. Actually, they are positive, but because they are having positive relationship, but because of multicolority, they become negative and so on, right? So these are the problems. Now, we will consider the detection. Multicolority is a rule, not exception, means it will always be there. So we don't discuss whether multicolority is there or not. So here the question is of degree, but not of the presence, right? So we consider degree should not be large. And this is important. Now, since it is not random, it is non-stochastic, deterministic, so there is no test. So how we check? So the most important two tools are variance inflation factor. Variance inflation factor gives rate at which variances increases. So if multicolority is high, then value of VIF would also be high, right? And what is the value? The thumb rule is if VIF is greater than 4, then we can have moderate multicolority. But if VIF is much greater than much higher, means greater than 9, then we can say that we are having very strong or severe multicolority. So they must be taken care of. Tolerance is simply the inverse of VIF. So let me show you the VIF values. So here we are having VIF values. Here values are 4, 4, 5, 5, 2, 2, right? So in 1, 2, 3, 4, we have VIF crossing 4, means we are having moderate multicolority, right? But obviously severe multicolority is not there. So we may think that there is a moderate multicolority, means somewhat high multicolority that can be taken care of. There is one more uh, tool to examine multicolority, and that is the conditional indices. Right? Now we are discussing the conditional indices. The rule is, thumb rule is, if all the conditional indices are below 10 or below 15, then we can say low multicolority. But if conditional indices are in between 10 to 25, we can say moderate multicolority. But if conditional indices are greater than 25, we have severe multicolority. So some researchers also suggest that if conditional indices are below 15, then they can be taken as acceptable and so on. So let us check the values of conditional indices also. So here conditional indices, here we are having conditional indices, right? Here the max, here we are having two values which are above 15. Sorry, there are three values which are above 15 and two values which are crossing 25. One is 26 and 34. So obviously it gives the impression of severe multicolority. So here we are getting the impression of moderate or somewhat high multicolority, but here we are having the impression of the severe multicolority. Means there is a problem of multicolority in the data, right? So we are having severe multicolority. So there must be some remedial measures. And the best remedial measures is employing principal component analysis or factor analysis. Probably you will cover this topic in some other lecture. There are some more methods also. We can use shrinkage estimators like ridge and lasso. So these are the things that can be taken care of if it is not following, means we are getting severe multicolority. But at present, we are not removing this. I am just explaining the concept. Next is related to autocorrelation. Autocorrelation means correlation between these two terms, means error terms, right? So it is actually the lag correlation in the same series that is known as autocorrelation. The impact is again the same. we are having high R square but insignificant predictor. So this is a problem. How it can be detected? We can use Durbin-Watson. Here the thumb value is 2 with a margin of 0.75, right? Means it would be 2 plus minus 0.75. So we are having values. If we use minus, then value is 1.25. And if we use plus, then the value is 2.75. Means if Durbin-Watson statistics lies in between these two values, we can say that we are having low autocorrelation. So let us check the value. Here the Durbin-Watson is 2.109. 2.109 lies in this range, right? Here the value of Durbin-Watson statistic comes out to be 2.019. It lies in the range. So we can say it is the having low autocorrelation. Obviously, it has a problem. It will be used only for a lag one. For the better test, we have run test or Grady test, and there are of a number of other measures also. We are not considering that. I am just introducing the concept. And if this is the problem, then there are some remedial measures. It has been mentioned. We can perform transformation or use some advanced method like Neve-West method to obtain a better standard error which is corrected for autocorrelation. So by this method, autocorrelation can be taken care of. Now we are having the last assumption that is related to homoscedasticity or heterosedasticity. Homoscedasticity means all the variance terms, all the error terms are having equal variance or constant variance. Then this is the homoscedasticity. If variances are not constant, as you see, with change of the error term, variances change, then we have a problem of heterosedasticity. Again, the problem is we have a large confidence interval, so they may give some misleading result. So how they can be detected? We will consider the regression plot. Now I am considering the regression plot. This is the scatter plot. And this is a scatter plot in between uh, standardized predicted value or standardized phi cap on the x-axis and standardized residual on the y-axis. If we are having a random distribution, as you are seeing, we are having a random distribution. The points are randomly plotted. Then we can say there is no problem of heterosedasticity. Data is quite random in nature, means they are having equal variance. Right? So I am going back to the slide. Right? So if we are having a random distribution of points, right? Like in this case, points are randomly distributed, right? Then we can say we have low or no heterosedasticity. Means no heterosedasticity. This is not a problem. Means data is primarily homoscedastic in nature. Okay. But if we don't have this, we have a well-defined shape. Suppose we are having a funnel shape. Means residuals are increasing with increase of y. We are having a funnel shape, right? We are having a funnel shape also, or a diamond shape, or a triangular shape. Means there is a consistent pattern. Then we can say there is a problem of heterosedasticity. So let me show you again. Here we are not having any funnel shape or the diamond shape or the triangular shape. So we can say we are having random pattern. So this is the case that they are homoscedasticity is being taken care of, right? So as we have discussed the regression part, including all the steps, as well as I have touched all the assumptions. Obviously, they demand a detailed discussion also that we taken care of in econometrics, or we take up the different chapters. In all the PPTs, you are having the description of everything. So let me show you the PPTs again. So they are very comprehensive in nature. means everything is being there. Right? So apart from the basic concept, even some important concepts are there, like the detection and the different methods, how they can, how we can use remedial measures. So as we have discussed, related to heterosedasticity, if we have large heterosedasticity, which is not in the case, then we can transform the variable. How these variables can be transformed? We can take square root, right? Means we can take square root of all the values by the transformation. We can use log transformation also. We take log values of this. So because of taking the log values of taking square root value, there will be less deviation. And because of less deviation, heterosedasticity has been reduced. There are some advanced methods also, like weighted least square method, where instead of ordinary least square method, we also use weights also. And there are some robust methods, like robust standard error of heterosedasticity, which is being termed as HSCE. That is, the full form is heterosedastically consistent standard errors, right? So if we take this case, then this problem of heterosedasticity can be taken care of. And the most popular method is White's HSCE. So you can use this method also. Okay. So this is all about the regression analysis. So we have discussed this concept. Hopefully the things are clear to you, and you can always discuss the concept. I have shared my phone number as well as my email ID. You can discuss the concept if you have any problem. So this is all about from my side. So I am closing off, and this is all about regression. And, and these PPTs and all these class notes will be shared with you, and you can have this. Thank you. All the best.